Tonight, we're going to talk about machine learning in a variety of applications. Let's introduce my partner here, Dr. Hashala. Sky did a good job of telling you his background. We've been working together for several years since he graduated from Westcliff, even though he lives in Egypt and I live in Arkansas. We're still meet every week, and thank goodness for Zoom. So tonight we're going to talk to you about how to apply machine learning for a variety of applications. And there's two parts to this talk. One is about the research process that we must establish, and the other is about the actual application of machine learning in your project. Well, the research life cycle has 8 different steps. We have the research problem and question, hypotheses, the target population, data collection, the instrument, data processing and analysis, and then we write up our results. I'm going to talk to you about the research life cycle first, through the way over here to data processing and analysis. And then Dr. Hashala will take over giving specifics on machine learning. When we're going to write our research problem, it's really important. I can't express how important it is to have a current program related to your field of interest. Ensure the problem is important in practical application, not just that there's a gap in the literature. Make sure in this situation that it can be solved by machine learning. And describe the problem with statistics so you can give evidence to know that there is an actual problem. You can write a problem statement in 1 or 2 sentences, and that will get the reader's buy-in. You, as a dissertation student, can also use it to guide your committee on understanding the problem you're investigating. So we first have to develop that research question. What is it we want to know about? It must be limited to the problem. It must be something that the problem can be solved by answering this research question. The question can be answered by the data collection and analysis process. And in this situation, it's machine learning. It's time limited, relevant to the field of study, realistic, and comprehensive. After the research question, we have to look to see if we've written a good one. Here's a question that is not a good one to write. Why is there a housing crisis in the Middle East? Now, it's not because there's not a housing crisis, but it's because why is not focused. It doesn't have a specific target. It's not measurable. Here's a better question. What impact does a continuing war in Sudan have on the affordability of housing in new compounds in Cairo? Well, after we've gotten a good research question, I'm going to skip these other 2 right now because they explain the same thing, that a research question has to be focused, specific. You can collect the data, it's researchable, and it's measurable. What do we do next? Next, we tell what we think is going to happen, and that's the hypotheses. It helps us focus and tells our prediction. It contains the variables we're going to use, what we're going to change and measure. There's a pair of hypotheses, at least, for every research question. There may be more, but they always come in pairs. The null is what is tested. The alternative is an educated guess. When we test the null, we come up with 2 options, whether we are going to retain it or reject it. And both are okay. Sometimes we wonder as researchers, is it okay if I don't find out that what I thought happened? But it is okay. Here's an example of a research question with an alternative hypothesis. Let's look at the second one. What's the difference between machine learning predictive power and the traditional method in forecasting consumer demand? The null hypothesis is machine learning does not have more predictive power in forecasting consumer demand than the traditional method. The alternative or research hypothesis is that machine learning has more predictive power in forecasting consumer demand than the traditional method. What we're going to do after we collect our data is build a model using the historical data. From this, we're going to use a t-test if we have a simple project, or an ANOVA, a type of ANOVA for multiple groups. Here's some instrument examples that you can use in a quantitative research project. And you can use all of these with machine learning. You can have a questionnaire, inventories, transactional tracking, social media, rating scales, surveys. There's a multitude of possibilities. I'm going to turn it over to Dr. Hashala now to bring us more into focus with machine learning.
Thanks, Dr. Andrews. So let me share my screen. Yeah. Is my screen visible now? Okay, good.
Yes, it is.
Thanks, Dr. Andrews. Now we learned the life cycle of how to make a good scientific research. Now we need to apply the machine learning concept in scientific research. But before we go that far, let's have a little brief about the machine learning. Why we need machine learning? What is machine learning? Machine learning actually is a branch of artificial intelligence. It tries to imitate the human brain in order to identify a pattern to analyze data. Since we have data available everywhere coming from home appliances, from IoT sensors, coming from social media, so we needed a tool to make sense of that data. So the machine learning is data-driven. All what we need to do is to provide good data, clean data to the application, and it will work its magic to identify a pattern to make a good prediction. And also, it's not explicit programming. You don't need to make a good, like a complex program. All what you need to provide is data. And also, the good thing about machine learning, it provides more non-linearity in order to match with the complexity of data available. Machine learning application can be written in different languages, such as R, Python, and others, but mainly we will focus on R and Python. So we have two types of machine learning: supervised machine learning and unsupervised machine learning. Suppose we need to make a prediction of a house price. So what we need to provide to the application is to provide independent variables and a dependent variable. Or let's talk machine learning terminology. We need to provide features and label. The features in our case will be like number of bedrooms, the age of the house, the space or the size of the house, the proximity to the ocean, and the label, of course, will be the price of the house. This is a kind of regression. For classification, the label will be either true or false. Suppose you need to identify an email, either spam or non-spam. On the other hand, we have unsupervised machine learning. Unsupervised machine learning, you don't need to provide labels. All what you need to provide is data. Let's take the example of housing price. So as a real estate company, you provide the application with all transactions, with all purchases done. And you ask the application or the machine learning application to identify groups or to cluster them into groups to check which group tends to buy a city center house, for example. Another example of unsupervised machine learning is association. You receive a recommendation of your next movie or your next song on YouTube or Netflix. This is a kind of association. Another example of association you can find in hypermarket. So the one who's like buying milk most probably will buy bread. That's why you can see bread and milk are close to each other. Here is a brief of application development plan. As we learned from Dr. Andrews, first step, you need to collect data. And for data collection, you need to provide the data in the form that machine learning application can understand. So you need to make something called pre-processing. Then you need to split the data into testing data set and training data set. In order to build the model, you need to go through 3 stages. You need to train the model, you need to make tweaks or tuning, and you need to test the model accuracy. After you are happy or you are assessing the accuracy of prediction, you can start deployment. Let's have some examples of machine learning applications. Suppose you have a company that providing mobile apps, and you need to have a tool to provide or to calculate the engineering hours of that mobile app. Another example is like to predict early diabetes and to forecast credit risk in bank sectors, or to forecast the demand of or the students' population in the next year, or to analyze or to make image processing for MRI, CT, X-rays to identify is it trauma or non-trauma. So we have here like your traditional way, and you apply the new concept, the machine learning concepts, and you compare the 2 methodologies, applying machine learning and your traditional way. So let's state the research problem for these 5 examples. How can machine learning improve the process of calculating software engineering hours or forecasting early diabetes, credit risk, predicting student prediction, or providing trauma diagnostics? So the next step, as we learned from Dr. Andrews, to state your hypothesis. We have 2 hypotheses. The null hypothesis that if you compare your machine learning methodology with your traditional or your classical way of calculation or prediction, so the null hypothesis will be there is no difference, or the machine learning does not improve the accuracy of prediction. And the alternative hypothesis, which we will be happy to prove, is that using machine learning model does improve the accuracy of prediction. How can we make that? How can we validate hypotheses? You can compare the accuracy of prediction by using root mean square error, or if you have multiple groups, you can use ANOVA. Here is an example of a published paper. They built a model to make early prediction of diabetes. They put some features like number of pregnancy, glucose level, blood pressure, skin thickness, insulin, body mass index, age, and job description. And of course, the label will be diabetic or non-diabetic. This is a kind of classification, as we know, it's a supervised machine learning. So we have here model evaluation. So normally in machine learning, we build different algorithms in order to compare and choose which algorithm fits more in my situation or my case study. And I don't need to mention that the one that giving highest accuracy in one example does not necessarily imply or apply to other examples. Here in our situation, we have logistic regression giving the highest accuracy, and on the right side, we have the confusion matrix. We have here some references, and these are our contacts, and we are happy to answer your questions. And also, we would be happy if you have any question, any support in your dissertation or your thesis, we will be more than happy. You can contact us. We will be more than happy to support. Now we are listening to your questions.
Hi, Kaki, or I'm not sure how to say your name. Did you have a question?
It's Kike. No, yes, thank you. I have a question about these names of machine learning and artificial intelligence. We have a big discussion with the professor a long time ago. My question is, why do we call this machine learning and artificial intelligence? Because there are a group of codes. It's like there's a group of codes and there's not necessarily, they are not learning. They are like, we are training the models for do better responses. And the other question that I have is, what do you think that will be the future of machine learning, artificial intelligence? Because right now there are news that Microsoft needs 4 nuclear plants to start working in their artificial intelligence. Apple is buying nuclear plants. So there is like it's like the cryptocurrency. They need a lot of energy for training the models. So what is the real future of this new way of coding?
So, Dr. Andres, so let me answer your. Okay, so let me answer your question, Kiki. So, for your first question, why we use machine learning and artificial intelligence? Artificial intelligence is a big umbrella. The machine learning is specified in analyzing data, and we have multiple algorithm inside. For the sake of time, I cannot list them here, and the list is extendable, by the way. For your second question, uh, what will be the future? The horizon is open for machine learning. Uh, let me quote one phrase from Dr. Andrew Ng. So Dr. Andrew Ng say that the machine learning is the new electricity and the data is the fuel for that. You can see machine learning everywhere in every industry. I'm not exaggerating if I say in every industry. Right now, you can see in medicine, in bioinformatics, in identifying gene disease, association, and you can find it everywhere, like banking sectors, in educational industries, everywhere you can find. But for the sake of time, just I like to take a second question. Yes.
Neda, what's your question?
Hello. Thank you for the very informative presentation. My question is, I'm doing the doctorate in business administration, and I'm in the process of writing my thesis, and I really like to use AI. I have some knowledge background on the different machine learning and data mining techniques. By chance, I used to work with the computer science students, but I want to know, like, as a business student, if you want to really write a thesis or dissertation in how deep we have to, like, can we use the available data mining tools, or do we have to implement it or code our own machine learning things? How do you think, can we use the available tools that out there?
Yeah. So, Dr. Andrews, let me answer this question. It's related to the programming. So yes, absolutely. The short answer is absolutely. And also I can provide you with some example of machine learning. Like I said, all what you need to bother is to provide with good database or good data set. And for others, it's easy. You can use, or we use ready-made libraries done in Python, in R, and you can contact me. I can support, and Dr. Andrews, of course, can support you in your making your dissertation. I can provide you with example of tools you can utilize, and you can provide the data in order to make analysis for that.
Thank you. That would be
Okay,
great.
Mr.
Yeah.
Zhang.
Hello. Yeah, very excellent speech for the machine learning. And I'm the first year DBA student at Westcliff, and I think in my future thesis I would like to apply some machine learning technique. But my problem will be like my computer resources is kind of limited. For example, if I want to run a large data set, I was wondering like for the Westcliff, do we have any like like a high
Group of
computation
computer.
center or something, so I can
We don't have that capability or right now for people to use.
okay, so any suggestions like what am I supposed to do if I want to finish the thesis to run a large data set using machine learning?
Yes, I have some suggestion about that. First of all, you can appoint some cloud. You can see like Microsoft Azure or IBM Watson. You can find some ready-made, and it's not expensive. It's relatively cheap. So you can prepare your database, and you can rent it for 1 month, 2 months, in order to make like a heavy analysis or data mining. But I would advise you to prepare your application algorithm in a sample of your data to check the healthiness of your application, and to get some results, to make sure that everything is wired correctly, is programmed in a proper way, and after that you can hire or you can rent a cloud for couple of months. That will not cost you a lot.
Thank you, Professor.
Okay, Mike. I guess he didn't have one. Abhijit.
Yes, Professor. Here is my only one question regarding to how we can manage the security for the data for the large number of data we have. So right now you said about the some health information of the say about the for the processing the machine learning algorithm. So how we can prevent that data for like the securing data from the data breach, and how we can manage that to in the future for the securing the personal data for that.
Yeah, okay. There is by the way, there is a session in maybe after half an hour or something about cybersecurity. So we can all together coming to that session to understand. But for a brief or for the short answer, you can make your data unlabeled, or sorry, for the sample recording, for names, for all personal information. You need to remove that from your database before processing or before putting that into cloud or for the any supercomputer. So you need to remove any personal information, any project name, any confidential data. This is step number one. But for cybersecurity, I'm not expert on that, but you can find more information about that in, like I said, in next room. Hope that, and also you can find some more information in the IRB methodology. This is something you have to take before accepting your proposal or dissertation proposal.
Okay, Mike. One more question probably is all we have time for. Mike, do you have a question?
Yeah, mute Mike. Yeah, maybe
I
he's
think
not.
Maybe he doesn't.
no, that's the time. One more time to us to finish the session. We're just on time. We have about a minute. And thanks you guys so much for attendance. Great presentation. And we'll see you guys for the next session. So we'll have like 5 minutes break. Then you'll be able to just switch to the different breakout rooms, or you can stay in this room. We're looking forward to see you at the next session. Thank you guys so much.